Hello everyone, welcome to Coders Camp. So we are at the last day of April LeetCode challenge and the problem we are going to cover is powerful integers. So we are given input of three integer values x, y and bound and we have to return the powerful integers within bound. So an integer is said to be powerful if it can be represented as x power I and y power j. And I and j can be any value which is greater than or equal to 0. So let's understand this problem with an example. So here is our given input value. This problem is not so tough a problem, quite an easy straightforward problem where our answers should be within the limit 10 and we have to return values in such a way that x power I and y power j must be less than or equal to bound. So in that case we have to try out all combinations of integers which are greater than or equal to 0 that satisfies the value that is less than or equal to bound. So let's start by having x power 0, which is 2 power 0 here, and y power 0, and the values are going to be 2. And moving forward, let's try 2 power 0 and 3 power 1. Same way, 2 power 1 and 3 power 0, and then 2 power 1 and 3 power 1. Then starts having by 2 power 2 plus 3 power 1 and other combinations of 2 comma 1 and goes to 3 comma 1 until both the limits exceeding bound. So in that case, we have to try out all combinations starting from 0 till the value is going to be less than or equal to 10. So sometimes only we'll be lucky to have our brute force solution itself as an optimal solution. So as this is going to be a brute force solution, we are going to have two for loops, which is going to iterate our values of I and j. So by keeping the i's value as constant, we are going to try out all possible j's value. For example, we are going to start having 2 power 0 and for that we are going to add it with 2 power 3 power 0, 3 power 1, 3 power 2, 3 power 3, so on until the whole limit exceeding 10. Same way, then we are going to keep 2 power 1 as constant and plus we are going to add other values of 3 power 0, 3 power 1, 3 power 2 and goes on. So this value goes till both x power I plus y power j goes greater than 10. So one thing we have to note here is what if any of the value of x or y is going to be 1. So if x is equal to 1, then 1 power anything is going to be 1. Same way, if y is equal to 1, 1 power anything is going to be 1. In that case, we don't have to really worry about all these combinations. Instead, we can simply add 1 instead of trying out all these combinations. So we are going to break our loop only at the places if our x or y is equal to 1. So hope you are understanding the solution, and this two loops are going to execute for every squares of I. For example, if first time x is calculated, then for the next time we are going to calculate x into x, and then the loop goes multiples of x every time. Same way, multiples of y every time. So consider n is the logarithmic sum of x and y is logarithmic sum of or powers of y. So in that case, big O of n plus m is going to be the time complexity of this solution. So let's go to the code now. So first start declaring a set which is going to hold all the values of a result. So let me have a for loop starts from 1. So every time I is going to increment by multiples of x. So here x power I is completely represented as I. So I is going to be I star x. So this is nothing but we are representing y power j completely as j. So every time we are going to add that to our set. So here instead of j, I'm going to compare I plus j is less than or equal to bound because we need to have the sum x power I plus y power j is less than or equal to bound. So here I represents x power I and j represents y power j. So if that is within the limit, we are going to add I plus j to our set. And finally return our result in form of array list. So this is done. And one more condition we have to check is at any point if x or y is equal to 1, we are going to break the loop. Y is equal to 1, then break. Same way, if x is equal to 1, then break. So yes, this is done. Let's run and try. So let's submit. Yes, the solution is accepted and runs in 1 millisecond. So thanks for watching the video. If you like the video, hit like and subscribe. Thank you.